IBS Industrialized Building System. Now we go to the next topic in IBS learning. You are going to learn in detail about precast concrete system, one of the main group of 5 IBS system in Malaysia.
Precast concrete system is a construction product. A construction product that is fabricated by casting concrete in a reusable mold. Reusable mold means that the mold can be used repetitively as long as the mold is in good condition. And the product is cured in a controlled environment. It can be controlled in terms of temperature, in terms of the quality, in terms of the peoples or labor. Stored mean that before it is going to be transported, it is stored in a yard nearby the factory, and later when it is required, transported to the construction site. When the concrete arrive, then the component will be lifted and assembled by a team of installer into position. Okay, this precast concrete system use a very minimum and little in situ construction. By applying the precast concrete system doesn't mean that in situ construction will not be going to use at all, but very minimum and very little in situ constructions apply in order to attach between the components. Okay, this is contra to conventional concrete, which is entirely cast in situ into formwork. Conventional concrete require use of timber formwork, and all the curing process is done at the construction site. Precast concrete is prefabricated in factory at a location away from the construction site. It means that the factories are not located nearby or at the construction site. It's located somewhere maybe far away from the construction site. And the components are manufactured using industrial method with mass productions. Because of the component is fabricated in factory, therefore the mass production can be used. So mass production's objective to produce large number of building with faster process and shorter period at lower cost. And finally, the quality of precast concrete component is much better compared to the conventional cast into concrete due to strict quality control. Because of the components is fabricated at factory, therefore the strict quality control can be imposed, can be applied to the product. Therefore a very much better quality of product can be produced. These are the examples of precast concrete system in various shapes and types. Precast concrete system may come in the form of wall panel with openings such as windows, can come in the form of solid wall panel, in the form of precast concrete stairs or staircase, a long and heavy girder or beam, a vertical wall panel components with opening or solid.
This is an example of building using full precast concrete system. Number one is precast wall panel, and this type of panel normally used for non-load bearing building. Number two is precast concrete columns. Number three is precast concrete beam. Precast concrete beam is supported by precast concrete columns. Number four is precast concrete bracing slab. This slab is connect between one side of beam to another side of beam. Number five is precast concrete wall panel, and this type of wall normally used for load bearing building, and sometimes can be used for non-load bearing building as well. Number six is precast concrete diaphragm slabs, and these types of arrangements is called diaphragm. And number seven is precast concrete foundation. Precast concrete system provides a number of advantages. Number one, precast concrete is cast off-site. The process to produce precast concrete can be done in a factory. Therefore, you don't have to bring all the raw materials to construction site for concreting process. Number two, identical formwork can be continually used. Because of formworks are made from steel, they can be used continually as long as the conditions are good. Number three, better quality control and overall construction quality. Precast concretes are normally uh, produced in a factory, and factories have a good quality control procedure, good machine, and good skilled worker, therefore contribute to the overall construction quality of product. Number four, control on curing. Because of precast concretes are produced in a factory, the curing process can be controlled, such as by using autoclave machines. Autoclave machines use steam to cure the concrete. Therefore, the temperature can be controlled and the time taken for curing process can be controlled as well. Number five, unaffected by weather. The casting process of precast concrete are done in a factory. Therefore, it is not subjected to any climate or weather disturbance. Number six, construction in less time. The process of casting precast concrete are done in a factory. Therefore, the only process left at the construction site is erection, and this can be done very quick. Number seven, less cost. Because of all the production of precast concrete is done at a factory, therefore less labor involved at construction site and less wastage uh, of materials. Number eight, residue materials can be used. Waste material produced from a factory, such as fly ash produced from electric power plant, can be incorporated to produce precast concrete. Number nine, fire resistant. Higher grade of precast concrete are produced in a factory. Therefore, fire resistance rate is better compared to a lower grade of uh, conventional concrete. Number 10, can avoid airborne pollution on site. Because of the productions of precast concrete done in a factory, therefore pollution of air can be reduced, such as dusting. Number 11, possibility of conversion, disassembling and moving to another site. Precast concrete system can be assembled and disassembled. Therefore, provide possibility of conversion and relocations to another site. The precast concrete component can be changed to another if required. Number 12, possibility of erection in area where traditional construction practice is not possible or difficult. In a small construction area, sometimes provide insufficient place to locate the raw materials. Therefore, precast concrete system can be used. Number 13, low labor intensivity. Very less labor are required at site because of all the production of precast concrete are done in factory. Number 14, reduce wastage of materials. Because of less raw materials required at the construction site, therefore this can reduce wastage. Number 15, easier management of construction site due to less labor, less machine, and less raw material. The only activities that require supervision at construction sites are the erections of the components. However, precast concrete system come with disadvantages. Number one, transportation is costly. This is due to the large components. If for small projects, the transportation cost is going to be very high. Number two, transportation and erection need to be designed in detail. Before produce any precast concrete, the erection methods and transportation journey need to be studied in advance. Number three, required different site or location or storage for its production. Precast concrete system require a dedicated location for its permanent factory or temporary factory. Number 4, very heavy members or components. Precast concrete components, normally large in size, resulted in a heavy in weight. Number 5, very small margin of errors due to highly precision measurement. Precast concrete system need to be produced in a highly precision measurement, otherwise it cannot fit during the installation. Number 6, connection joints between panels may be difficult and complicated. In precast concrete system, the connections and joints are not simple. They are very complicated. Number 7. Somewhat limited building design flexibility. In precast concrete system, the shape and designs are based on the formwork, and this limit the flexibility. Number 8. Economic of scales due to demand for regularly shaped buildings. Economic of sales can only be achieved if regular shaped buildings are used. Number 9. Need repetition of forms may affect building design. Because of the repetition use of formworks, the building design cannot be varies. Number 10. Small number of units prove to be uneconomical. Precast concrete system need to be used in a big project. For a small project, the cost is going to be very high. Number 11. Heavy duty cranes are required to lift and handling panels. Because precast concrete components are large in size and heavy, therefore you need a heavy duty cranes for lifting and handling. Number 12. Skilled worker is required. You need skilled workers to install and assemble panel or components at site. Number 13. Require waterproofing. Precast concrete system require good waterproofing, otherwise leakage may happen. This is the point comparison between site cast in situ and precast. Number 1, site cast in situ definitely require no transportation because all activity carried out in situ at the location, including erection of formwork, process of concreting, striking formwork, curing, and others. Okay, meanwhile, for precast concrete, definitely require transportation because of all the components are fabricated in a factory in other location, so therefore all the components need to be transported using vehicle to the construction site. Okay, number 2, the size limit for site cast. The size limitation is depend on the elevation capacity only. This is apply where all the materials need to be carried out uh, to the upper level for constructions of high-rise buildings. Meanwhile, for precast concrete, the size limitation of the component is depend on the elevation and the transportation capacity. Okay, the size of the component need to be fit with the vehicle that is used to transport the component, and when arrive at the construction site, the machine that is going to lift or elevate the component must have the required capacity. Number 3, site cast in situ normally lower quality because the work always affected by weather such as rain, storms, and meanwhile for precast concrete, the component fabrication less affected by weather because they are produced in covered and proper area. And number 4, site cast in situ normally require large space for work, for storage, for movements. Meanwhile, for precast concrete system, you don't require a large space because all the fabrications are done in the factory. The design concept of precast concrete building is based on three factors. Number one, buildability. The component shapes and design must be possible to build using the available formal system in the factory. Number two, economic. A huge amount of money or capital need to be invested in order to set up factories, machine and workers. Therefore, a large scale of project is required to ensure return on investment or profit. Number three is standardization. All the components fabricated need to come in standard size in order to achieve buildability and economy. Because concrete components normally large in size and very heavy, therefore it requires equipment and tools for handling, lifting and installing, such as mobile crane for lower story of building and tower crane for higher story of building. And those cranes must come with lifting tools such as spreader beams or wire rope slings to lift lift the components from the transporter to the locations. And rigging tool needs to be properly located within the components such as eyebolt, shackles, and hooks. This is to facilitate during the lifting and handling process. The manufacturing of precast concrete components can be done in two ways. Number one is by factory prefabrication of sites. These methods require a permanent factory to be set up at a location in which it is surrounded by the ongoing construction project, so that the factory has opportunity to supply all the precast concrete components and generate income. Number two is by site prefabrications on site, and this method requires a temporary yard to be set up within or near the construction site for the prefabrication process. For factory prefabrications, a standardized component can be produced uh, on a long-term basis because the factory is permanent, and the work can be done throughout the year without interrupt by the climate or weather. And because of this, a high level of mechanization or full use of machine can be achieved. For site prefabrication, it requires a temporary yard to be set up within the site or as near as possible to the site, probably not too far. And this system is used when it involves a specific job, and that job is only for a certain period of time. Okay, the execution normally consists of two methods. First is semi-mechanized. In this method, works are carried out in open space without shed, and the labor are locally outsourced. This system also use minor equipment and a few mold or formworks. Second is fully mechanized. This system carry out under a fully shed or covered, and all the labor are skilled, and the equipment is similar to the equipment used in factory productions. Precast concrete component. There are various precast concrete components available, and they can be assembled, connected and joined with one and another components to form a complete building or a structure. The typical structure component used are normally wall panels, beams, columns, floor slabs, and staircase. The precast concrete components normally are very huge in size and very heavy. Thus, it requires a large vehicle for transportation. So the components must be designed according to the limitations of the vehicle in terms of size. And precast concrete components also require heavy duty crane for handling and lifting, and the crane must have the required capacity for handling and lifting to avoid accidents. Basically, there are 5 types of IBS precast concrete component. Number 1, precast concrete slab. Precast concrete slab is the horizontal structural member because it is installed in a horizontal orientation. It is normally used for floor slab and roof decks and can be designed as one-way or two-way slab. Normally, precast concrete slabs come in half and acting or functioning as a formwork. When cast in situ concrete is formed on the top parts of the precast concrete slab. It is also can be integrated and connected with other precast or in situ components such as beams and walls. There are 4 types of precast concrete slab. Number 1 is solid flat slab. Solid flat slab is fabricated as a solid object without any hole or void. Number 2, hollow core slabs. This type of slabs is fabricated with a series of void and hollow to incorporate insulations or any utilities such as conduits and wiring. Number 3 is double T slab. Double T slab consists of two shapes of T. And number 4 is single T, which consists of one T shape. Both solid flat slab and hollow core slabs are normally used for shorter span slab. However, double T and single T are normally used for a long span slab, but with less thickness. These are the examples of solid flat slabs, hollow core slabs, double T slabs, and single T slabs. This is an example of the lifting process of a precast concrete floor slab into its positions, and another photo here showing that a worker is laying services pipe and services conduits on the precast concrete floor slab after it was installed prior to receive cast in situ slabs on top of the precast concrete slab. This is the example of prefabrications of precast hollow slabs, which comes in various thickness and hollow size, as can be seen in this photo. And this is the machine used to cut the slab at the required spans. This is the overview in the factory when the productions of precast hollow slab is carried out. This is how the machine lifts the fabricated hollow slab to be transferred uh, for transportations, and this is how the lifting process and the handling process of the hollow slabs when it comes to installations at construction site. Before any precast concrete slab system is selected, there are factors to be considered. Number one, maximum span. If shorter span is required, perhaps solid flat slab and hollow core slabs are more suitable. If a longer span is needed, uh, double T and single T slabs are more appropriate. Number two, nature of support. Whether the slabs are going to be supported by precast concrete column, beam or wall panels. Number three, weight of units. If lightweight slab is required, perhaps precast hollow core slabs is more appropriate. Number four, thickness of units. Solid flat slabs and hollow core slabs are thicker compared to double T and single T. If less thickness slab is required by the project, maybe double T or single T slabs are more appropriate. Number 5 is thermal insulation, and number 6 is sound insulation. If the projects require insulation to be incorporated in the floor slabs, perhaps the more appropriate system is hollow core slabs. Number 2, precast concrete beam. Precast concrete beam is the horizontal structural member to carry flexural and shear loads, and also provide support for floor slabs, and can be made in various sizes depend on the required design and specification. For internal beam, the cross section is symmetrical. This is to support the floor slab on both edge and sides of the beam. For external beam, the shape is asymmetrical because only one side is required to support floor slabs. Precast concrete beams come in four normal shapes, standard shape, which are rectangular, L-shaped, inverted T, and AASHTO. Precast concrete beam normally fabricated in standard size. This is to minimize costs and accelerates the manufacturing process. Precast concrete beam also fabricated with projecting reinforcement, for the purpose of connection between other components such as slabs and column. Precast concrete beams is to provide support for slab as previously mentioned, and the precast concrete beam is provided with projecting reinforcement bar that will going to be bond with other components. This is the examples of the projecting reinforcing bar. And this is the four standard shapes of precast concrete beam. This is the rectangular beams. This is L-shaped beam. This is inverted T beam. This is AASHTO beam. This is the examples of how AASHTO beams looks like. The beams is supported by concrete column with connections called corbel. This is how precast concrete column supports precast concrete beam by using a connection called corbel. Okay, this is examples of corbel. Sometimes AASHTO beam is incorporated with pre-stressing technology. This is how the reinforcement bar is arranged in AASHTO beam, in which can be seen here the main bar is located at the top parts of the beam and the bottom parts of the beam. This is because of compressions occur at the top parts and tensions occur at the lower part. Therefore, by incorporating pre-stressing technique to both parts of reinforcement bar, this could increase the strength of the beam. Number 3 is precast concrete column. Precast concrete column is the vertical structural member used to provide support for beams. And precast concrete column usually carry axial loads or vertical loads, and is designed and manufactured either in single or double story height for the purpose of easy handling and transportation. Columns are higher or longer than single or double story may face difficulties during transportation using trailer and lifting using a crane. And the columns, even though manufactured in single or double story height, they can be assembled to one another to achieve the required heights. If a 15-story building is about to be constructed and the precast column is fabricated in a single story height, therefore the column can be connected to one another until the height is achieved. And precast concrete columns can be fabricated in circular shapes, square, rectangle, and any custom shapes that's required. And it is the standardizations of the column size or height that minimize cost and contribute in the acceleration of the manufacturing process. However, if there is a long slender columns need to be constructed, it may incorporate a pre-stress system in the reinforcement bar to provide more resistance to bending during the installations and handling. This is the examples of precast concrete column. During installation, push-pull prop is required as a temporary support to provide stability to the column during installation. This is samples of detailed connections column to footing. This is the pad footing. This is the pile, and this is the precast concrete column. So the main bar, the starter bar from pad footing will be inserted in the hole at the bottom of the column. Then after that, a concrete grout or cement mortar will be injected into this hole to provide stiffness or strength to the connection. This is where the grout hole is located for mortar injection or grout injection. This is examples of the higher precast concrete column. Number 4, precast concrete wall panel. Precast concrete wall panel is a large planes of vertical components, either load bearing to carry loads, or precast wall panel can function as a non-load bearing structure. If precast concrete wall panel load bearing, it can be incorporated with cobble to provide connections and support for floor slabs. Precast concrete wall panel may fabricated as solids, hollow, sandwich, T, and rib, and may contain aesthetic and functional features during fabrication, such as insulation, wiring, windows and doors. And the wall panels can be fabricated to either one-story heights or several-story heights, as long it does not exceed the limitations, maximums of transportable length and lifting constraints. However, for precast concrete non-load bearing wall, it is not subjected to any load from any members. Therefore, precast concrete non-load bearing wall can be made less dense to reduce the weight. This is the examples of the precast concrete wall panels. As you can see here, wall panel can be fabricated to up to several story height, as long as it does not exceed the limitations for transportable length and lifting capacity. This is the solid wall panel. This is the hollow core wall panels, and this is T wall panels. This is another example of a precast wall panel systems. As you can see here, the wall panel is fabricated with fittings and features. Okay. Pre-cut openings such as windows can be seen here. The additional features of architectural components there, and this is examples of wall panels installations, and you can observe here there are temporary bracings installed everywhere to support and stabilize the wall panel during the installations. This is the examples of a solid precast wall panel, and this is examples of a reed precast wall panel. This is wall panels supported by temporary bracings. You can see here that the large size of panels is fabricated and installed, and this is how the panel is lifted by the cranes for installations. And the wall panel must be incorporated with hook for the crane to lift the panel safely, and push and pull prop is required as a temporary bracing to support the wall panel during the installations. In this example, you can see push and pull prop is used to provide support and stability to precast concrete wall panel during installations. And this is how a precast wall panel is transported to construction sites from the factory using the lorry or trailer and lifted by a crane. Number 5, precast concrete staircase. Precast concrete staircase is an elevated structure members connected from lower floor level to upper floor level and can be manufactured with or without landing slab, and projecting steel is provided at the staircase for connections between landing and other components. Smooth and quality finish can be produced because of the formworks capable of producing such smooth finish, and it was the standardizations of the size, the width, the rise, the threads that makes the productions economical. This is the examples of precast concrete staircase. Look at the photo here. This staircase is connected between the up or lower floor level to upper floor level, and provided with projecting steel for connection with other components such as slab. This is the steel formwork used to fabricate the precast concrete staircase. This is how the precast concrete staircase is stacked before transported for installations, and this is examples of precast concrete staircase installed. Assembly concept for precast concrete building. Assembly concept for precast concrete building is that one component is supported by other precast concrete components. Okay, this diagram shows that the precast floor slab is supported vertically by the precast concrete beam, and this precast concrete beam is supported vertically by the precast concrete column. Okay, and in this photo here showing that the floor slab is supported vertically by the precast concrete wall panel. This is the precast concrete wall panel. This is the close-up look showing that the double T floor slab is supported by beams and column. Okay, this parts of floor slab is supported by the precast concrete beams, and the precast concrete beams here is supported by the neat connections of precast concrete columns. This is the close-up photo showing that the hollow core slabs is supported on the load-bearing precast concrete wall panel. This is the precast concrete wall panel, and this is the hollow core slabs. This close-up photo shows a precast concrete double T slab supported on precast concrete load-bearing walls and inverted T beams. This is the double T slabs, and one edge of the slab is supported by corbel connections from the precast concrete wall panel load-bearing, and the other edge of double T slab is supported by corbel from inverted T beams. This is inverted T beams. This is an example of precast concrete slab is supported by precast concrete wall panel. As you can see here, the slab is supported by the concrete wall panel. Okay, this is examples of double T floor slabs and supported by the precast concrete wall panel using the corbel connections methods. Joints and connections. Joints and connections are the most crucial parts to be considered because they are the weakest point in the structure that need to be given special attentions. Therefore, it is important to establish satisfactory structural connections and joint, because if failure occurs at the joint, the structure may collapse and damage. The major structural joints for precast concrete systems are beam to column, column to column, column to base, beam to slab, slab to slab, and slab to wall panel. And the joints and connection must have required strength, stiffness, ductility, and reliability to ensure stability. There are three types of joints normally used for precast concrete components. Number one is called compressive joint. This type of joint uses cement mortar to resist compressive force between vertical jointed precast components. Number two is called tensile joints. This type of joint uses overlap steel bars, dowel, and welding to resist tensile forces between horizontally jointed precast components. And number three is called shear joint. This type of joint uses shear keys as interlocking to resist shear forces between horizontally joined precast components. There are four types of connections often used with precast concrete system. Number one is called reinforced concrete corbel. Cobble is a types of connections incorporate in precast concrete columns, okay, which uses what is called concrete bracket to provide support for beam ends. An examples of cobbles use is that it allows immediate release of beams from the crane hook after installations. Number 2 is called reinforced concrete nib. This connection use protruding parts for columns, beams or wall for support. Number 3 is called beam half joint. Okay, this connection use recess at the edge of beam for support, such as this. This is called beam half joints. Number 4 is called shear key. This connection use structural parts formed as a key to resist sliding, such as a key. Okay, this is called a structure shear key. This diagram shows the examples of joints and connections. Okay, this is RC, reinforced concrete cobble. Okay, reinforced concrete cobble is used to support precast concrete beams. Normally, reinforced concrete cobble is used in precast concrete column. Okay, secondly is reinforced concrete nibs. Reinforced concrete nibs also used to support other precast concrete components such as precast concrete beams. Okay, this is beam half joint. This connection used for connections between beam, one beam to the other beams. And finally, shear key joints. This is the shear key joints to prevent sliding movement. This is an example of slab to slab connections. This is one component of slab. This is another component of slab jointed together, and sealant is used to cover the gap between the two slab components, and a plate is used to tie between the two slabs, and the plate is strengthened by using a bolt. This is the examples of connection between wall panels and column. This is wall panel 1, this is wall panel 2, and this is steel column. The connection use standard clips. This is standard clips, and the standard clips is welded to the steel column, and bolt is used to connect between the clips and the wall panel, and the gap between wall panels can later be filled with grout or cement mortar. This is the examples of connection between precast concrete floor slab with precast concrete wall panels, whereby a projecting starter bar coming out from bottom wall panel is used to connect to the upper wall panel through the precast concrete slabs by using steel plates, and there is a holes here called pockets that will be filled in with grout after the connections is secure between the steel bar, and the hole or the gaps between the slabs and the wall panel will be filled with mortar or grout here. Another common method of attachment between precast concrete member is by using steel plates, which is embedded in the component of precast concrete, such as this is for wall panel and this is for concrete floor slabs. And these two steel plates are welded to provide strong connections.
This is an example of a connection between slabs and beams by using reinforcement bar and grout. Uh, so this is the precast slab. This is the another precast slabs and jointed together by using the reinforcement bar. So the reinforcement bar is placed to connect between the two slabs, and grout is applied onto the reinforcement bar and in between the precast component slabs. So therefore this is the grout apply in this area to connect between the two precast slabs and beam. Okay, this is the beam. This is an example of precast wall panels during the construction process. This is the wall components and support by temporary struts or support in order for the wall panel to stand in stables. Okay, later the gap between the wall panel will be casted by in situ construction. So this is the column casted by in situ construction to connect between this wall panels and another wall panel. This is the wall panel waiting to be installed and stacked together before being lifted for assemble. This is examples of precast concrete slab. Okay, precast concrete slabs component laid. Okay, laid component laid between them, and later reinforcement bar is installed in between the slab component, and on top of the slab precast concrete slabs, BRC and another reinforcement are laid and any conduit or electrical services or plumbing will be installed, and later concrete will be poured on top of all the precast concrete component and reinforcement bar to connect all the components until they become homogeneous like this. This is the connection systems for precast concrete beams by using corbel and nib. The beam or the precast concrete beam is going to be fabricated with this kind of shapes to allow connections with other beams. Okay, this is examples of nip. Nip has this connection called unchamfered edge. Okay, unchamfered edge, whereby this is parts in which another beam is going to be joined in this position. And this is a corbel connection, corbel system, whereby the beam will have this part protruding from the original column, and this corbel is the locations or position in which another or other beams will be connected here. Okay, this is beam, this is column. So the beam and the column are connected by using this is what they call corbel system. Okay, this is how the reinforcement bar are installed to form the corbel system. This is the connection system for slab to beam. Okay, in these examples, as you can see, this is the slab. This is the slab. Connect to the precast concrete beam. This is beam. So therefore, a well plate connections are used to connect or join between the slab and the beam, and reinforcement bars are installed in this position here, going through the holes in the precast concrete column prepared earlier. Therefore, this slab with two slab and precast concrete beam and precast concrete columns will be connect using the in situ construction in this location. Okay, this is examples of precast hollow slabs connected to precast concrete beam and precast concrete column. Okay, you can see the corbel system here used to connect between beam and the precast columns. Later, slabs, beam and columns jointed together or connect together using the in situ constructions in between, so in the spaces between them. Okay, this is another view of precast concrete slabs, precast concrete beam and precast concrete column connection. This is the double T concrete beam. Okay, supported at these positions on the precast concrete beam, and the beam is support by the column using precast corbel systems here and here. This is the examples of a connection system for beam to beam. As you can see, reinforcement bars are used to connect between both beam, and later the empty space here is going to be connect or apply with concrete or grout to establish a secure connection between both beam. And this is how the reinforcement bars are arranged in between the connections of between the two beams. This is example of connection systems used for column to column. Okay, this is the upper column. This is the bottom column. Later connected using this bolt and nut prepared earlier in the factory and connect at the construction site. Later the empty space here is going to be grout, okay, to establish a secure connection. And this is how the reinforcement bars are arranged at the edge of connections. This is the connections for wall to slab. As you can see, the precast concrete slabs jointed or connected to precast wall panel using a corbel system. And this is the example of connection systems for column or precast concrete column to precast concrete base. This is another types of connection system between precast concrete column to precast concrete foundations or precast concrete base. Therefore, in conclusion, the use of precast concrete systems shows increase year by year. The use of precast concrete constructions able to reduce construction waste, reduce the impact on the environment, enhance quality controls of concrete, reduce the direct labor on site, increase safety for the workers. However, the hurdle or the impediments by applying precast concrete system has caused the transportation difficulties, inflexibility, and require more advanced procurement. That's all for the lessons this time. Thank you very much.